Hi there, Esther. I'm looking at this problem and I'm not sure if you're looking for volume or surface area. So I'm not quite sure, but in looking at the other clips and I see volume here, I'm going to assume it's volume. So I'm going to pretend as if we're working on volume. We need to backtrack just a little bit. That reference booklet I gave you, you need to go to this page. We need to talk about prisms. When you have a prism, and we do volume equations, like the simple volume equation for a prism is base times height. That capital B means area of the base. So every time you see a capital B, it means area of the base. So the most important skill in dealing with prisms is to ask yourself, where are the bases? The bases have these three qualities. There's two of them and they are congruent. The bases are parallel to each other and there's nothing but rectangles that connect them. C, P, R. So right here, we're gonna just shade the bases. That's all we're gonna do. So for this, the bases would be the top and bottom regular pentagon. Here, the bases would be the two trapezoids. Why? Because these two trapezoids are congruent, they are parallel to each other, and everything that connects them is a rectangle. Here, your bases would be these two. Here, your two bases for the can are going to be the two circles. Here, your base are the triangles. So when we talk about area or volume, your capital B changes. To find the area of a regular polygon, its perimeter times the apothem over 2. To find the area of a trapezoid, it's the parallel sides averaged. That would be the two greens here because they're parallel. Averaged, add, divide by 2, times the height of the trapezoid, which is that right there at a right angle. This RB would simply be length times width. This RB, which is our base, is a circle. So it's pi r squared. Apple pie is really, really good. And if this was a right triangular, this would be leg times leg over 2. All of these area equations are what capital B would be on the next page of your reference booklet. So on the next page of your reference booklet, the volume of a prism is going to be area of one base times the height. And for this one, it's going to be area of one base times the height. Remember the bases, they are congruent, they are parallel, and there's nothing but rectangles that connect them. It's really easy to see there in a can, this label thing is a rectangle. So volume equation of prisms and cylinders is area of the base times the height. Area of. Going back to your problem, right here, this is a trapezoidal prism. So your bases I think I have it. Is that it? Nope. Where did I load it? There? Nope. I'm just going to do it again. Grab that. I'm going to come here and add a random page. There it is. And there we go. So here our bases are going to be the front and back trapezoid. The front and back trapezoid. And then your height is the distance between the bases, which is right there. So let me pull out that trapezoid. And then how do we find the area of said trapezoid? The base area. This is going to be the parallel sides, which are lowercase base, averaged. So base 1, base 2 over 2 times the height of the trapezoid. So coming here, one base, 18, plus the other base, 4 over 2, times your height, looks like that's 12. So I'm going to go 11 times 12. I got 132. So volume equals base times height of the prism. Our base, we just found, our base here is 132 units squared. And then the height of the prism is that edge right there, which I think is 5. Let's double check. Yeah, 5. Got it. So times 5. So we're doing 132 times 5, 10, 15, 16, carry the 1, 5, 6. So the volume is 660 units cubed.